In the previous video we had taken one set of readings, that is we had kept VGS as 1 volt and we had taken readings along VDS and ID. Now we are going to increase on VGS, right? So already we had kept 1 volt. Now by adjusting RPS we are increasing to for the 2.5. okay, so I am writing here, that is VGS 2.5 volt. Now we will check how much current will flow in that, right? That is in drain current. First initial value 0 0, that is initial value you should write as 0 0. So here it is here also I forgot to write initial value, always 0 0. okay, now I am increasing some volt, that is I will kept as a 0.2. okay, that is here it is a 1.9 and the current is 0.2. 1.9 current 0.2. now I am again increasing further voltage, that is 0.4. the current is 0.6. 0.4, 0.6. I will increase further voltage, 0.9 for the current is 1 milliamps. 0.9 for the current is 1 milliamps. So 1.4, what about the current? Current is 1.3. 1.4, current is 1.3. Another last voltage 1.82 and the current 1.4. see, the current is stable, that is current is less than 2 volt, current is less than 2 milliamps. Here the current is approximately 5. When I am increasing further greater voltage, current gets increases, but here it will not move above 2. Suppose if I am increasing gate to source voltage as 4, now we will check this. See, so whatever you will increase the current, whatever you increase drain to source voltage, your current will be 0, because depletion region touch both the depletion region touch together, so no chance of flow of electrons. okay, right. So this is gate to source voltage, we will reduce to 0. Now we had completed the drain characteristics. Now we will move for transfer characteristics. Transfer characteristics, first we have to keep one value as constant in VDS, drain to source voltage, then we will increase VGS. At the time we have to look out what about the current, because the graph should be like this, that is current initially the current should be at greater, and when the voltage increases your current gets reduced to 0, right? First we will increase VDS. So this is VGS, this is VDS ID. So we will keep one voltage as constant in VDS. For example 0.6, I am keeping 0.6 as a constant, 0.6 voltage as a constant here. So for the 0.6 your current is somewhat 2.9. now what is the actual drain transfer characteristics? VGS and ID, we have to increase the voltage across VGS and we have to check the current. See, this is VGS, this is ID. So here we have to increase some volt. See what happens, first we will see what will happen. if I am increasing VGS first meter voltmeter, automatically the current gets reduces. Alright, this is the thing we are going to plot. So initial value, first value, it is VGS 0. What about the in ammeter? 2.9. So first value 0, 2.9. 0, 2.9. Second, we will increase some voltage. So 0.4 in volt, VGS is 0.4. Here 2.5, 2.7. 0.4, 2.7. See, the current gets reduces. Again, I'm further increasing the voltage here. I will keep as 1.5 volt, voltage 1.5. What about the current? Current 2.2. See, 1.5, 2.2. I will keep 3. 3 for 3, the current is 0.4. For 3, current is 0.4. I am keeping 4. That is 4 point. That is 4. What about the current? 0. It's just 4. The current is 0. I will increase for another 1 volt. 5. Current is 0. So 5 for 5 volt also the current 0. Okay. Now for another set of readings. For another set of readings, again we have to make it a 0. Initially we had kept 0.6 volt, and now we have to increase a greater voltage 0.8 or 1. See, in this voltmeter drain to source, I am increasing to 1 volt. For 1 volt, I am writing this is for 1 volt. What about voltmeter? Voltmeter is 0. Current 4.3 milliamps. Voltmeter 0, 4.3 milliamps. So I will take 4 readings. For first reading, for 1 volt. What about the current? 3.6. For 1 volt, 3.6. Now I am again increasing for 2 volt. For 2, 2.3. For 2, 2.3. Another one, 3.7 volt. For 3.7, 0. For 3.7, value 0. Okay. And last volt, 5.5 remains 0. So 5.5 also remains 0. Clear? Okay. So VGS should be kept 0. We have to make it as 0. See, while making VGS 0, your current gets increases. Okay. And when everything you should be make it as 0 before switching off the supply. Okay. Thank you. So we had completed Jfet drain and transfer characteristics.